Every time you take a medicine, you're placing your trust in this massive, incredibly complex system. But what are the invisible guardrails that make sure the pills in your cabinet are actually safe and effective? Well, that's what we're going to explore. It's a pretty provocative question, right? But it cuts right to the heart of medical progress. When your doctor deviates from the textbook, are they giving you cutting-edge care? Or are they basically running an experiment on you? There's a really fine line there, and it's protected by these crucial, but often totally invisible, systems that are designed to keep you safe. Look, we all want medical breakthroughs. Of course we do. We want new cures, we want better treatments. But history has taught us a tough lesson. Unchecked progress can be incredibly dangerous. So this is the story of how we try to balance that need for speed and innovation with the absolute, non-negotiable necessity of patient safety. And we're not just talking about some administrative paperwork here. As this quote gets at, the accuracy and the reliability of the data behind every single drug, well, it can literally be the difference between a treatment that works and one that causes serious, serious harm. 41,000. This number, it represents the 41,000 breast cancer patients who got a highly toxic, incredibly expensive bone marrow transplant treatment. It was pushed forward because it showed some early promise, but that was before rigorous trials proved it was no better than the existing, safer options. It's just this stark reminder of the human cost when innovation goes wrong. So how do we prevent this from happening? Well, it all starts with the very first guardrail, the rules of data. So our first and most fundamental guardrail is something called data integrity. The best way to think about this is as the bedrock of trust. It's a whole set of rules that ensures the information supporting every single drug is solid, reliable, and totally uncompromised. So what does that actually mean in the real world? It means that from the very first molecule that's tested in a lab, through the whole manufacturing process, and all the way to the final pill you hold in your hand, every single piece of data has to be trustworthy and provably unchanged. Now, what's really fascinating is how regulators actually enforce this. They use a checklist, and it's known as ALCOA++. As you can see here, it's a list of principles that sound pretty simple but are incredibly powerful. For instance, data has to be attributable, which just means we know who did what and when, and it has to be contemporaneous, recorded the second it happens. This whole framework makes sure nothing is left to chance. This is really all about accountability. In the world of making and researching drugs, there are no anonymous actions, not a single one. Every measurement, every entry, every signature is tied directly to a specific person at a specific moment in time. It creates this crystal clear chain of responsibility. Now, this might seem, kind of obvious, but this rule is absolutely crucial. Recording data contemporaneously, meaning at the exact time it happens, prevents all those little memory errors or backdating or even just guesswork from creeping into records that are used to make literal life or death decisions. Okay, so having reliable data is one thing, but it's really only half the story. Beyond all the spreadsheets and lab reports, there's a second, equally important guardrail. And this one governs the very human act of a doctor trying something new to help a patient. To really get the ethics here, it's critical to see the difference between a few key things. On one side, you've got standard practice. That's using the proven methods. On the other end, there's formal research, which follows a super strict protocol to create new knowledge for everybody. But innovation, it lives in that gray area right in the middle, where a doctor departs from the standard to try and help one specific patient. So to help doctors navigate that tricky gray area, the American Medical Association provides this ethical framework. It says that before trying something new, a doctor has to make sure the idea is based on real science, not just a hunch, that they actually have the skills to do it, that their only motive is the patient's well-being, and that they've talked it over with their peers. These frameworks for data and ethics are absolutely essential. But what happens when they break down? When these guardrails fail, the consequences are swift and they are serious. And not just for patients, but for the companies and the doctors involved too. This real-world example shows you that there's a direct and surprisingly quick line from a failed inspection to a public warning letter. The FDA finds problems, the company can't fix them properly, and boom, the result is formal, public action that can wreck a company's reputation and even lead to shutdowns. So why do these systems even fail in the first place? Well, these are the usual suspects. It can be something as simple as human error or just sloppy paperwork. But it also includes bigger challenges, like outdated computer systems that don't have the right audit trails, or even sophisticated cyber attacks targeting that sensitive data. Okay, so as medicine is rapidly entering this new era of artificial intelligence, wearable sensors, and medical apps, the old guardrails, well, they aren't always going to be enough. Regulators know this, and they're working right now to upgrade these systems for the 21st century. A key part of this upgrade is the FDA's Digital Health Center of Excellence. Now, this is not just another stuffy government office. Think of it more as a strategic initiative designed to proactively engage with and regulate this whole new world of digital health. Everything from software that can diagnose disease to the apps on your phone that monitor your health. So here's the crucial point. Instead of just reacting to new technology after it's already out there, the FDA is trying to get ahead of the curve. The whole goal is to build partnerships with tech companies and create these flexible, modern regulatory paths that can actually foster responsible innovation right from the very beginning. And this right here perfectly represents the fundamental shift that's happening. Regulatory oversight is moving from the world of physical things, like inspecting factories that make pills, to the world of intangible data, software, and algorithms that are going to define the future of medicine. And that leaves us with the essential question we have to keep asking. As technology accelerates, as medicine becomes more powerful and more personalized than ever before, can our systems of trust, our data, and our ethical guardrails, can they evolve fast enough to keep us all safe?